Welcome to our mathematics class. In this particular video, I'll continue to look at financial mathematics, and in particular, I want to focus on annuities and their present values. Annuities and their present values. In our Zika quantitative analysis syllabus, we only deal with two types of annuities, and these are ordinary annuities and due annuities. What is an ordinary annuity? And to begin with, what is an annuity? Annuity is simply equal payments made at equal time intervals, a series of payments made at equal time intervals. That's what an annuity is. So let's explain what an ordinary annuity is. Ordinary annuity is an annuity where payments are made at the end of the period. Payments are made at the end of the period. For example, a salary, if you are getting a fixed salary at the end of a given period, that is going to form an ordinary annuity because the salary is paid at the end of the period. Number two, due annuity. What is a due annuity? A due annuity is an annuity where the payments are made at the beginning of the period. Payments are made at the beginning of the period. An example of a due annuity will be rent. You will pay rent at the beginning of the period. So if you are paying a fixed amount of rent at the beginning of every period, then that will form a due annuity. So let's look at these series of payments that are made at equal time intervals, annuities. The formula for ordinary annuity is given as follows: A equals to P multiplied by 1 plus R to the power n minus 1 over R. The P in that formula is the annuity, is the payment that you are making every end of the period. And A is going to be the total sum that will accrue in that account after a given number of periods. Due annuity, where the payments are made at the beginning of the period, we have that as the formula for due annuities. The difference between the two formula is the 1 plus R here, 1 plus R. So let me explain the reason why we have that difference between the two formulas. We've said ordinary annuity, you are making payments at the end of the period. So let's look at the numbers down here as time points when you are making those payments, representing an ordinary annuity. So if you are making at the end of payments at the end of the period, the first payment you will make it at the end of period 1, which is the start of the second period, the second payment, the third payment, and the fourth payment. So you will notice that by the time you are making your last payment, your annuity account would have matured. So this is the end of all periods. This is the end of the periods. So by the time you are making your last payment, the account has matured. Wow, a due annuity, you are making a payment at the beginning of the period, making a payment at the beginning of the period. So your first payment will be made at year 0, then you make that second payment, you make that payment, you make the fourth payment. You will notice that by the time you are making your fourth payment, your money has to be in the account for the last 1 year. The last 1 year, that's the due annuity. This is the reason why after we calculate the total amounts paid up to that point, we have to multiply everything by 1 plus R. So 1 plus R is compounding for the last 1 year that your money will be in the account. The last 1 year, the money will be in the account. I hope you have noticed the difference between the two. With the ordinary annuity, the moment you make your last payment, the account has matured. As for the due annuity, when you make your last payment, your money has to be in the account for another 1 year before it matures. That's why we are multiplying by 1 plus R. 1 plus R. The present value of annuities, This is all annuity payments converted to the present amounts, and the formula for the present value of annuities is given as follows: PV of an annuity equals to P, which is the annuity, then 1 minus 1 plus R to the power negative n divided by R. Let's look at the perpetuity. What's the perpetuity? When the present value of annuities continues for an indefinitely long period of time, we have what we call a perpetuity. So these are annuities that are almost endless. And the formula for calculating a perpetuity is present value of a perpetuity will be equals to the annuity itself, A, the perpetuity, divided by R. So let's look at examples. Example number 1. Example number 1. Mr. Zimba deposits 40 kwacha at the end of each quarter in an account offering 4% interest compounded quarterly for 4 years. So, as part of the solution, you need to first of all identify the variables that are given. So we have P, which is the annuity itself, the amount paid in the account each period, and that annuity is 40. We have R given also. R is 4%, which is 0.04. Now, because interest is compounded quarterly, so our R will be divided by 4, and that will give us a 0.01. What else do we have on the given variables? Is the period of time. We are dealing with a period of 4 years, but because interest is calculated every quarter, we multiply by the 4 quarters in each year. So that brings us to the total of 16 periods. So there will be 16 periods, there will be 16 compoundings that will happen. So what are we looking for? Calculate the expected sum. So the expected sum according to the formula. Let's also notice another thing. We are told that these payments are made at the end of the period. So this is an ordinary annuity. And how did we know in the first place that we are dealing with an annuity? Is because payments are made each period, meaning that it's not a one-off payment. It's a series of payments that are made every quarter. So these are the two things we looked at for us to identify this is an annuity, and also to know that this is an ordinary annuity. So we get the ordinary annuity formula. So drop down the formula to be part of your solution, then substitute what you have in the formula. So what is our P? Our P is 40. Then what is our R? Our R is 0.01. And what is our N? Our N is 16. We have 16 periods. So our R there is 0.01. Okay, so those are the figures or variables that we've been given in the question. So let's calculate how much that will result in. Let's see. So if you tap everything in the calculator, you should have the following figures. So divided by R, you should have 17.26, and your P is 40, of course. So what will be your final answer? So your A will be equals to, if you tap all those figures in your calculator, we are dealing with kwacha, so you should have 690 kwacha 0.14 way. 690 kwacha 0.14 way. So that's how much will be in the account after 4 years if interest is at 4% compounded quarterly for Mr. Zimba, who deposits 40 kwacha every quarter of the year. So let's move on to the second example. Example number 2. A woman invests 2,000 now and a further 2,000 each year for 7 more years. How much would the total investment be worth after 8 years if interest is earned at the rate of 6% per annum? Okay, so now what we are noting is that there is a payment 2,000 that is made now. So now is year 0, it's at the beginning of the period, and further 2,000. So equal amounts are made each year. So that tells us it's an annuity. If you are making payments every period, that's an annuity each year for 7 years. So the total payments are going to be 8 payments. The payment now, which is in the first year, and the further 7 payments. So how much will be in the investment after 8 years? Okay. So let's see solution. This is a due annuity. Why? Because payments are made at the beginning of the period. The first payment is made now. So let's get our due annuity formula. That's our due annuity formula. Drop it down to your solution and then begin to substitute. So what are the variables that we have been given? We have been given the annuity itself, the P, and P is 2,000. What else are we given? We are given the rate, R. R is 0.06, that's a 6%. This time around we are compounding annually, so there is no need to worry about adjusting that rate. And we are also given the N. N is 8. Now we have 8 periods. So let's substitute in our formula. So substituting there, you have your P, that is going to be 2,000, then your R will be 0.06, N is going to be 8 years, R is 0.06, then the R there will be 0.06. Okay, so tap that in the calculator. Please be able to follow BIDMAS rule. First start with the brackets, then move to powers, then deal with the -1 divided by 0.06, then also that part worked together, then multiply with the last part there. And after you do that, you should have your A equals to 20,982.63. Wow, that should be your final answer. That should be your final answer. That should be your final answer. So let's do that. Okay, so back to the question. The question says, how much would the total investment be worth after 5 years? So after 5 years, you expect the investment to be 20,982.63. So we've just looked at 2 important parts in dealing with annuities, the two types of annuities, ordinary annuity and annuity due. Let me remind you about the difference between the two. Ordinary annuity payments are made at the end of the period. Due annuity payments are made at the beginning of the period. That's why we have this part as an adjustment to the formula. So those two questions done. Let's now move on to example number 3. Find the present value of an annuity of $450,000 per month for 3 years at an interest rate of 6.5 compounded monthly. Here we are dealing with a present value, the present value of an annuity. So all you need to do is go back to our formulas and get the present value of an annuity. That's a present value of an annuity. Present value of an annuity formula. So bring it down. That is going to form part of your solution. Of course, identify the variables. So what variables do we have? We have our P, that's the 450,000. We have our N, that's the 3 years compounded monthly. That is going to be 3 multiplied by 12, 36 months. And we have the rate, which is the rate which is 6.5. So that R 6.5 is going to be 0.065, and because we are dealing with 12 months per year, adjust it like that by dividing it. You should have 0.0054. Let me also just put down the P. Our P is 450,000. And our N is 3 years, but we are compounding monthly, so it's 3 multiplied by 12 months. That makes a year equals to 36. Substitute that in your formula. So you have your P, 450,000. You have your R, 0.0054. You have your N, that's a negative 36. You have your R down there, that is going to be 0.0054. Let's create space between the two parts. So when you do that, get a calculator. Please take care of BIDMAS rule. So it's 1 plus 0.054 raised to power 36. Then use power negative 36. Then you say 1 minus the answer. Then divided by that. Lastly, multiply by that. When you do that, your PV, present value of this annuity, must be equals to, we dealing with kwacha, so kwacha, this is going to be 14,686 and 731.77. That should be your final answer. After calculating. So please just take time to go through and recalculate these figures and just verify and have a feel of what is going on here. Otherwise, this is a part of mathematics that you can enjoy doing. Now let's deal with the last example for this video, for this session. Find the present value of 25,000 received annually in arrears at a discount of 7.5%, received indefinitely. So this is a perpetuity, received annually. There is no limit in terms of number of years. So this annuity will take a very long period of time. So it's a perpetuity. So what's the formula for calculating the present value of a perpetuity? Just go up there and get the formula for calculating the present value of a perpetuity. Present value of a perpetuity. So this is going to be PV equals to, what's the annuity? 25,000 divided by, what's the rate? 0.075. 0.075, and if you tap that in your calculator, you should have, we're dealing with kwacha, you should have 333.33. So that is going to be the present value of a 25,000 received annually, indefinitely, without limit. Thank you so much for taking time to view this video. Please, if you have comments or questions on financial mathematics, annuities, and the present value of annuities, don't forget to write in the commentary boxes. Send me questions, send me some comments, and if this has worked for you, give it a thumb up. That's the only way I can know that we are interacting. Thank you so much. Take care of yourself and make sure that you are preparing for your final exams this coming June.